Hi there, in this video I'm going to do a past exam question on differentiation. So let's take a look at this question. So question number 7, the curve C has equation y equals f of x, where x is not equal to 0, and the point P, which has coordinates 2, 1, lies on C. Given that f prime x is equal to 3x squared minus 6 minus 8 over x squared, in part A of the problem, find f of x. So let's see how this is done. Let's go back to the paper and pen. So we have f primed x. So f primed, in other words, is the derivative of f of x. And to work out f of x from the derivative, what we need to do is we need to integrate f primed x with respect to x. So that's the idea over here. So we need to find f of x. We have f primed of x, the derivative. So remember, we need to integrate to find f of x. Now, let's replace f primed. So we'll have f of x, which is the integral of 3x squared minus 6 minus 8 over x squared with respect to x. So I can rewrite the 8 over x squared as, so let's rewrite this integral as 3x squared minus 6 minus 8 over x squared is the same as minus 8x to the minus 2. And now we're in a position to integrate because our terms are of the form ax to the power of n. So remember the idea of integration, add 1 to the power, divide by the resulting power. So if I integrate 3x squared, I'll get 3x cubed divided by 3. When I integrate 6, it's 6x. And when I integrate minus 8x to the minus 2, so when I add 1 to the power, minus 2 plus 1 is minus 1. Divide by the resulting power, minus 1. And let's add a constant of integration as the integral doesn't have any limits. So if we simplify, going one extra step, f of x will be, these two 3's we can cancel to give us x cubes minus 6x. Minus and minus is plus, and it's plus 8. X to the power minus 1 we could write as 1 over x plus the c. So this is f of x with the constant. Now if we go back to the question, so we've been given this information that the point P having coordinates 2, 1 lies on C. So we can use the x and y coordinates of this point to find the value of the integration constant. So back to the paper and pen. So we've been given this point P 2, 1. So 2, 1 refers to the x and the y value. So let's replace it in our f of x. So remember, f of x is the same as y equaling this particular expression. So if I replace the x and y values in, y replaced by 1, that is equal to x replaced by 2, so it's 2 cubed, minus 6 into x replaced by 2, plus 8 over x replaced by 2, plus c. So that is what you should have upon replacement of x and y. Let's simplify. So 1 on the left is equal to 2 cubed being 8, 6 into 2, which is 12, 8 divided by 2, which is 4, plus c. And if we rearrange, as 8 minus 12 plus 4 is 0, I make c 1. So that should be the value of c. So if I therefore replace the c here in our general solution, we're going to get a particular solution. So the particular solution is f of x, and upon replacement we'll have x cubed minus 6x plus 8 over x plus c. C is 1. So that should be the solution to the first part of the problem. Now let's go back to the screenshot. So in part B, Part B reads, find an equation of the tangent to C at the point P, given your answer in the form y equals mx plus c, and m and c are integers. So let's think about this problem. Let's see how we're going to solve this, and let's go back to the paper and pen. Now, bearing in mind, in the question we have f primed of x, so we have the derivative. Now we can use the derivative and the x coordinate of P to find the gradient of the tangent. So let's use the derivative. So in other words, we have dy over dx, and let's use the x coordinate of P. So remember, the coordinates of P given is 2, 1, and let's use the x coordinate, which is 2, to find the gradient of the tangent. So let's work out firstly the gradient of the tangent. I normally call the tangent gradient m1, so let's work out m1. So if I replace x by 2 in our f primed, we're going to have 3 into x replaced by 2, so 2 squared, minus the 6, minus the 8, divided by x replaced by 2, so 2 squared. So if we calculate that, if you simplify that, you should get an answer of 4. So 4 being the gradient of the tangent. Now we've got the gradient of the tangent, and the tangent passes through the point 2, 1. So since the tangent is a line, we can use the equation of the line formula. So the equation of the tangent at P, which has coordinates 2, 1. Let's use the equation of the line formula, y minus y1, that is m into x minus x1. So in the formula, m is the gradient of the tangent, so m is m1, m1 being 4, and the tangent passes through 2 and 1, meaning that x1 and y1, so x1 and y1 are the coordinate 2 and 1. So with this data, let's replace. So we're going to have y minus y1, which is 1. That is m is 4, into x minus and x1, which is 2. Now if we get rid of the brackets, we'll have y minus 1 on the left. That is equal to 4 times x, which is 4x, 4 times minus 2, which is minus 8. And if I take the minus 1 to the right, we have y is equal to 4x minus 8 plus 1 is minus 7. So that should be the solution to part B, that is the equation of the tangent. So remember, we need it in the form y equals mx plus c, and that is the very reason why I have it in that form. So that's the solution to part B, and that is the end of the question. That sadly also ends the video, so I hope you found this video helpful. I hope you enjoyed this video. If you're unaware in terms of how to work out the equation of the tangent and normal, I'll provide a link to a video that I've done previously in the description below, which gives you the method in terms of how it's done, but it also gives you additional examples. So I'll provide a link again to those particular videos in the description below. Other than that, I hope to see you again. Thank you.